Hi, welcome to Computer Science Explained. In this video, we will talk about the laws of Boolean algebra. We need the laws of Boolean algebra to simplify logical formulas. A simplified formula gives the same output but is more concise. Formula simplification is significant for computer programs and crucial for logical hardware circuits. Computer programs with simplified logical formulas are faster, consume less energy, and emit less heat. Logical hardware circuits with simplified logical formulas, in addition to the previous three merits, are more reliable and cheap to produce. Annulment laws. These laws describe situations where the value of an input variable doesn't affect the result. The first law: x or true equals true. False or true equals true. True or true equals true. So the result is true no matter what value has input variable x. All or x is all. The second law: x and false equals false. False and false equals false. True and false equals false. So the result is false no matter what value has input variable x. Nothing and x is nothing. Identity laws. The first law: x or false equals x. False or false equals false. True or false equals true. X or nothing is x. The second law: x and true equals x. False and true equals false. True and true equals true. All and x equals x. Idempotent laws. The first law: x or x equals x. False or false equals false. True or true equals true. The second law: x and x equals x. False and false equals false. True and true equals true. Complement laws. The first law: x or not x equals true. Not false equals true. False or true equals true. Not true equals false. True or false equals true. X or not x is all. The second law: x and not x equals false. Not false equals true. False and true equals false. Not true equals false. True and false equals false. X and not x is nothing. Double negation law. Not x equals x. Not false equals true. Not true equals false. Not true equals false. Not false equals true. Not x is all except x. Not x is all except not x and equals x. Associative laws. The first law. Let's first see the arithmetic analog of this law. In this formula, we can see that the disposition of parentheses does not affect the result. Let's check the corresponding logical law. As we can see, this law is correct. X or Y or Z is the same as Y or Z or X. The second law. All the same as the first law, but with multiplicative operations instead of additive. Let's check. As we can see, this law is also correct. X and Y and Z is the same as Y and Z and X. Commutative laws. The first law. Let's look at the arithmetic counterpart. 2 plus 3 equals 3 plus 2. In other words, the left and right operands of the plus operator are equivalent and interchangeable. The same is true for the logical OR operator. Let's check with the truth table. As we can see, this law is correct. The second law. It is almost like the first, but multiplication and logical AND are used. Let's check with the truth table. As we can see, this law is correct. Distributive laws. The first law. Let's look at the arithmetic counterpart. This is the logical variant of this law. Let's check with the truth table. As we can see, this law is correct. The second law has no arithmetic counterpart. Let's check this law with the truth table. As we can see, this law is correct. Absorptive or redundancy laws. The first law. Let's check this law with the truth table. As we can see, this law is correct. The second law. Let's check this law with the truth table. As we can see, this law is correct. Thanks for watching. See you next time.